Hello, everyone. Welcome to Science on Tap. Good evening, everyone. Hello.
Good evening, Carol.
Welcome to Science on Tap, Amy Monday. Thanks for coming. My name is Carol Warden. Science on Tap is an example of the Wisconsin idea, an idea conceived in 1905 that the borders of the university are the borders of the state. Our partners in Science on Tap include Rocky Reef Brewing. Thank you very much. The Lakeland chapter of the Wisconsin Alumni Association, UW-Kemp Natural Resources Station, UW-Trout Lake Station, Minocqua Public Library, and WXPR Radio. Science on Tap is supported through a grant from the Brittingham Fund to the University of Wisconsin-Madison. There's 3 ways to watch. Join us right here in person. Thank you all for coming. Packed house tonight. You can also watch on YouTube live. You can ask questions there in the comment box, and there's a link for that on our website, scienceontapminocqua.org. And you can also watch the event later, so you can go to that website and click on past events, and we'll have it archived there. Our next event is on Thursday, February 6th, and it will be right here, of course, and we'll be hearing from Mark Pauley of Wisconsin DNR, and he will be talking about PFAS, or forever chemicals, in our water. Tonight, we have Dr. Tom Robick speaking about the fishes of Lake Superior. Dr. Robick was born and raised right here in Lac du Flambeau, Wisconsin. He received his high school diploma from Lakeland Union High School in 1988. His Bachelor's of Science degree in biology from the University of Wisconsin Stevens Point, and then his Master of Science and PhD in Oceanography and Limnology from the University of Wisconsin-Madison. He gained employment at the University of Wisconsin-Madison as an associate scientist, and he conducted research on lakes in the Northern Highlands Forest until January of 2001. When he was appointed to the faculty of Department of Biology at the University of Minnesota Duluth. He received tenure and promotion to associate professor at UMD in 2006, then full professor in 2013, and subsequently head of the Department of Biology from 2016 to 2019. Dr. Robick holds graduate appointments in the Integrated Biosciences program at UMD and in the Water Resources Science program at University of Minnesota St. Paul campus. His teaching and research interests generally address aquatic diversity, aquatic ecology, and the use of sonar technology, conservation biology, and aquatic food web interactions. His research publications can be found in journals focusing in the field of aquatic ecology, and has extramural funding to conduct research on Lake Superior, as well as small lakes in Wisconsin and Minnesota. Dr. Robick's current research projects include lab experiments on the visual acuity of deep water fishes in Lake Superior, field experiments in small lakes of Minnesota and Wisconsin, food web and fisheries dynamics in the Great Lakes, and the effects of climate change on cold water fish species, which I'm sure we'll hear about tonight. Per tradition, we have a story and trivia question. One summer, Tom was working on Trout Lake Station, doing some sonar work for some of our long-term research lakes in the area. And this work required only one person, so he was out on his own this day. And even for seasoned veterans like himself, when it comes to field work, sometimes even in the best circumstances, things don't go as you'd expect on the lake. On this particular day, Tom found himself in a pickle. So your question is, what went awry for him on this particular summer day? A, he dropped an untethered $15,000 sonar into the deepest part of the lake and had to get a dive team to recover it. B, he buried the truck in the sand in the launch while trying to load the boat on the trailer and had to run 3 miles back to the station to get help. Or C, his motor completely unhinged from the transom from the boat while driving full speed back to the launch. So we have A, drop the $15,000 sand. B, buried the truck and had to run 3 miles to get help, or C, lost the motor off the transom? For Tom, it was only B, burying the truck and had to run back to the station. However, all of those things have happened from people housed out of UW Trout Lake. Dr. Tom Robick.
Thank you. Thank you. How's the sound, Noah? Yep, okay. Well, I'm so honored to be here with you all and on this wonderfully chilly night. Figured I would start out by just sharing a few things about myself. Like Carol said, I'm local, and it's really kind of an interesting feeling coming back and talking at an informal event here, which I remember this place was a auto parts store not that long ago. But one of the reasons that I ended up at UMD was because of Lake Superior. I had some opportunities to go elsewhere, and the lake has just enamored me since before I was even working at Trout Lake. My dad used to take me up to a couple of the rivers up there in the springtime, and it's just always fascinated me. And to me, it's the greatest lake in the world. It's the world's largest freshwater lake by surface area, and it's in the top 20 for sure by volume. It contains 10% of the world's surface fresh water. So those are pretty big numbers. The amount of water in Lake Superior is as much as in the rest of the Laurentian Great Lakes. So to me, Lake Superior is just one of those special places. The other interesting thing about Lake Superior is that it's dominated by native species. It's unique in the Laurentian Great Lakes in that regard. The rest of them are dominated by invasives that have come in through various routes, including ballast water and swimming through various canals and around the Niagara Escarpment. The fish assemblage in Lake Superior is wonderfully diverse, and there's some very unique species there. There's around 85 fish species in the lake. And I've been lucky enough to be studying it for around 30 years. The first research cruise I went out on was in 1995, so it was really an interesting experience for somebody, at the end of their master's to be able to go out on a research vessel for a couple days. And the only reason I ended up on the boat was because I was the only one that knew how to use the sonar unit, and the person that was supposed to know how to use it couldn't get it to run right. So I ended up getting invited because of that. But I never really forgot the experience of being out there. And just the power of the lake. It's over 350 miles long, over 150 miles wide. And when you get out into the middle of it and there's a front coming in, you can feel tension. You can feel the respect that everybody should show that place. So it's, to me, it's one of those really special places that everybody should spend as much time around as possible. The interesting thing about the native species in the lake, to me, are the deep water species. So many of those 85 different fish species live in what we call the near shore. And the near shore in Lake Superior is 85 meters and shallower. So we don't really have any 80-meter deep lakes anywhere. Not even Trout Lake. Trout Lake's 30 meters deep. 35, yeah. Depending on what year, right? No, and who's measuring it. But 80 meters is still where light penetrates to the bottom, so you can still get algae growing on the bottom and 75 meters of water, and it's really just an absolutely clear, beautiful, pristine place. The offshore then is 80 meters out to, it's 1,400 feet deep. It's just one of those great basins of open water. And some of these fish species, are very comfortable on the bottom at 400 meters, and they come all the way up to shallow water at night. And they do that every day. It's called diel vertical migration, or daily vertical movements. And so these fish actually never see the light. They never see direct sunlight. They're always avoiding it. They go deep during the day to avoid being seen by predatory fish, and the predatory fish follow them down. And they're really well adapted to these vertical movements. There's three really common, numerically the most common species out there are the cisco, which is very common around here as well. It's found in deep lakes like Trout Lake. And then there's two very closely related species, one called the bloater, which is Coregonus hoyi, which is the thing you see most of the time in grocery stores called smoked chubs. And then there's what's called the big eye cisco, or Coregonus kai, which is a very unique species. That's the deepest water species. And it's a little smaller, and it has much longer paired fins. And their eye is about 3/4 of the width of their head. So they're really interesting fish that look like they should be in the ocean. One of those, if you're in a submarine, you see those strange fish with big eyes, and they're really neat fish. And they have all sort of other subtle different characteristics, like different sized gill rakers, and which allow them to feed on different sized prey. And then the other major component of the deep water food web are the lake trout. And there's one particular morphotype of lake trout, which is a subspecies called the ciscoette. In Ojibwe, that means it cooks itself. So these things are so much fat that if you put them on a fire, they'll burn. And so they're up to about 60% fat by weight. And that's an adaptation to allow them to go up and down at will. They don't need a swim bladder to maintain buoyancy. And so that allows them to follow their prey wherever they go. And they go wherever they want. The prey do this really consistent vertical movement, and the ciscoette will follow them. But if they find a good food resource, they'll stay in shallow water if they want to, or they'll stay in deep water if they find a lot of benthic fish. There's a lot of benthic fish as well. There's some really neat native sculpins, which often are called muddler minnows, and they don't get very big. There's one species called the deep water sculpin that I've seen get to maybe 8 or 9 inches, and then there's a spoonhead sculpin, which is intermediate in depth. Deep waters can be found all the way to the deepest areas of Lake Superior. Spoonheads are at intermediate depths, along with slimy sculpin, and then mottled sculpin are usually found very close to shore, and then what's called coastal areas, where it would be 10 meters or less in depth. So the food web is really, it differs depending on what depth zone you're in, and the behavior of the fishes differ as well. So they do these dynamic vertical migrations from very deep water, usually near the bottom, to the surface. And some of the earlier work that I did showed that varied seasonally. So one of the species in particular, the one that's common around here, the cisco, only vertically moves consistently in the summertime. Does anybody know why that would be? Plankton? That's part of it. Cold water? Light, right. Who said light? So the angle of the sun gets much steeper in the summertime. So light penetration is further down. And so to get out of the light, they have to go further. And like I said, the ciscoette can stay up in the water column all day. They're not afraid of anything. And to get away from that in the summer, they move. But in spring and fall, they don't really go very far. So The Cisco's in the middle of the summer will go down to about 120 meters and stay there. Bloater and Kai will go down to at least 150 meters to 200 meters every day. So they'll move from 200 meters to the maybe 80 feet deep at night, feed at a layer. Usually there's a deep chlorophyll layer there where there's a lot of plankton. They'll feed there and then they'll get out. They'll move before dawn. And they go down really fast. They'll come up slowly in the evening and then they'll go down really fast right before the light starts. So that was why we started to look at their visual acuity in the lab to see how much light do they need to see, how much light do they need to feed, and it's remarkably little light. You can't see in it. I have this lab in the basement of Swenson Science Building that we've got the same light spectrum that downwells in the lake, and when you turn it up really high, you can see it's really cool bluish green light. And but when you turn it down to what they actually feed at, you absolutely can't see anything. So it's really an interesting set of adaptations. They can the Cisco lake trout can feed at about 220 meters during the day, 220 meters in depth, which is incredibly deep. And then they can feed by starlight at night at even like 30 meters in depth. It's pretty crazy. So those are a lot of the things that I studied. Putting the behaviors together allowed us to also look at species interactions, and I had a few grad students working on establishing the diet content of thousands of fish, and we put it all together in an ecosystem model to try and estimate how the food web might change if invasive species increased, if certain species that were at one time abundant. So rainbow smelt was abundant one time, and we were looking at potential for changes related to food web dynamics, and also potential impacts at that time for a change in fisheries. And it turns out that the food web is very stable because of these behavioral dynamics. It dampens predator-prey interactions. And the invasive species tend to be really hit hard by native predators when the predators are abundant. Rainbow smelt is down to just a shadow of the former biomass from the 60s and 70s. If anybody remembers back then, the smelt would come into the rivers and the river level would go up. That's how many smelt there were. But they're down in, like I said, the food web's dominated by native species now. The other interesting thing that I recently studied was looking at isolated shoal complexes, and there's one in the center of the lake called Lake Superior Shoals. Does anybody know about that one? It's right in the middle of the lake. There is one point on it that comes up to about 12 feet, so you don't want to hit that if you've got a big boat. But most of it is usually between 50 and 80 meters on top, and so it's in the light, and there's remarkable fish production on that reef, and so we were trying to figure out what was causing that, and so some of the plankton, one in particular called mysis, which is a shrimp that looks a lot like krill, if you're familiar with krill. And these things do the same vertical movement for the same reason. They're getting away from predation during the daylight. And those things come up at night and they drift over these shoals. And then when it starts to get light, they get trapped on top. And then there's a morphotype of lake trout called the humper, which is only found on these mid-lake reefs or humps that feeds almost exclusively on mysis. So this morphotype of lake trout has evolved to feed on that excess in those areas. There's another morphotype of lake trout that I have to mention too, called the redfin. It's the most beautiful trout this side of a brook trout that you'll ever see. These lake trout get extremely large, and they have long, really magnificent fins. They almost look like a guppy, and they're bright red, and I'm sure it's related to selection on the spawning grounds, but they're found at intermediate depths and really pretty abundant around Isle Royal and on Stannard Rock and on Lake Superior Shoals as well. So some folks may be wondering, why is Lake Superior dominated by native species? And the primary reason for that, and let's say Lake Michigan and Lake Ontario are not, and especially Lake Erie. Those lakes have a different climate regime, first of all, and second of all, they're not as big or deep. So the Lake Superior holds the cold a lot better. And so the cold temperatures that Lake Superior has throughout most of the year, the only time you ever really see a thermocline is in July, late July, and into if you get a really warm year, but sometimes it's even August into September, and that's not a lot of warm water for some of these species that are adapted to warmer temperatures that are invasive. And so things like alewife just barely are holding on in Lake Superior, and the native species are all cold adapted. And so Lake Superior is holding on to these native processes. Everything is fairly stable because the predator-prey interactions are dampened by these co-evolved behaviors. And as we see the change happening in Lake Superior, which is warming, we're seeing less ice every year, potentially could lead to hotspots of new species starting to dominate. And the invasives that are there that are likely candidates are round goby, Eurasian ruff. Those are the two big ones. Rainbow smelt probably won't come back as long as the lake trout are managed correctly. And so I thought I might leave it there and open it up for questions.
All right. Tonight, we have Katie with the mic right here. So raise your hand if you have a question. Katie will come to you, and wait till you have that mic so the people online listening can hear you and so the rest of the room can hear you.
Thank you, Dr. Robick.
Hi, Uncle.
From a game fish perspective, has there been sampling to see what heavy metals may be in there for all the years of acidification?
There has been a few studies of toxins and metal accumulation, and oddly enough, Lake Superior, I don't think it's directly related to acidification, but it is related to the configuration of the food web. So Lake Superior does have higher PCB concentrations than you would expect, and it's because the food web is dominated by bacteria and what's called the microbial loop. So there's a piece of the what we would call a subweb of the whole food web. Imagine a food web with 65 species in it, which are abundant enough to measure. And then there's this little piece of it down by the algae or the plants that are primary producers that provide energy. The bacteria are the biggest box in that whole food web. If you look at the fish that we consume, you can imagine a pinpoint in the box with bacteria are this big. And so the bacteria get consumed by ciliates and protozoans, and the protozoans get consumed by zooplankton, and the bacteria recycle the nutrients that used to be zooplankton, and the thing spins. And when that happens, all of the metals that get processed at each of those points accumulates because PCBs are sticky and don't turn over quickly. And things like mercury do the same thing. They don't turn over quickly. And so because the microbial loop is such a big component of the food web, as the zooplankton nutrition moves up into the planktivorous fish, they're already pretty high. And so the PCB concentrations of fish that eat planktivorous fish are a little bit higher than you would expect. Yeah, Stephanie Guilford wrote a nice paper on that a few years back. I don't know what to do.
Oh, I'm sorry, you want to go first? I was at UW-Mass probably about the time you were, or maybe before, in the days of Hassler and his undergraduate. I learned one thing called optimal foraging. That, of course, back then we applied it to fish only. Okay, but a thing's going to eat the biggest thing it can swallow and the most abundant. Okay, so we proved it at all trophic levels, correct? Okay, that's a simple concept. So when you add non-native species like we have in our Great Lakes, and I remember when the lake trout population plummeted, and that's when we had problems with exotics or invasives. So what's your message to us on how to handle exotics and invasives? And then my other question is deeper than this. Geologically and geographically, what was the origin of the fishes that are in Lake Superior? Going back 25,000 years ago.
This could take a while, yeah. Well, I'll start with the invasives, and really the thing that altered the food web in Lake Superior was the sea lamprey. So by the 50s, they were already increasing. So that was I would call that a highly impactful invasive that knocked down lake trout. There was some evidence that commercial fishing had knocked some of the, especially major populations down. But sea lamprey came in and finished them off. So then there was a big release from predation for the rainbow smelt to take advantage of. And they negatively impact the ciscos pretty significantly. And so rainbow smelt exploded. I guess the main message there would be, let's try not to knock down the top predator if we can manage it. And most fisheries do try and, every fishery is managed for some level of exploitation. But we've seen it even in these smaller lakes in the Northern Highland, where you knock walleye down far enough, rainbow smelt will dominate. But if you let them come back, rainbow smelt doesn't dominate. And then you get cisco back and yellow perch back. So that would be one message, is careful management of the top predator is probably a smart thing. You get a quality fishery, you may not be able to keep 5 a day, but they'll be there, and the food web will be in good shape. As far as where did all the fish come from, that's a really long story. So there's the first set of fish that are dominant in Lake Superior, if we just keep it to Lake Superior, are what are called proglacial species. So they come as the glaciers periodically advance. There's what are called proglacial lakes, which extend significantly in front of the glaciers, like bigger than Lake Superior. These proglacial lakes, there's been many of them, but some of those species will just go back and forth with the leading edge of that glacier, and some of them ended up in Lake Superior. And so a couple of them that I'm thinking, well, lake trout are obviously one. The sculpin species are another one, and the ciscos are another one. But not all the ciscos, I think, were derived from these proglacial advances. Some of them were endemics, including I'm sure somebody's going to ask me about it, so I'll leave it alone. But there's a few of them that, there was one that was recently re-identified in the lake, called the short nose. That one and one called the long jaw are thought to have endemized in the lake, so they're not found anywhere else. But some of the other ones, like cisco and bloater and short jaw and blackfin ciscos, there's a variety of different cisco species in there, and they're found in Canada in a variety of lakes up there. But during one of those glacial advances, the outlet of Lake Superior was blocked for a while, and it drained through the Brule River into the St. Croix and down the Mississippi. and there was an influx of species from the south. So I think a lot of those warmer water species like the centrarchid bluegills bass, some of the minnows and sucker species came through that corridor. And so there's a really interesting combination of those groups of species there. And I'm working on Isle Royal right now where different lake stages and different glacial lakes inundated the island differently. So there, on the higher lakes, there's only a few species from the first major lake, and the second inundation was brought in a few more, and that last one brought in all the ones from the Mississippi drainage. So we're looking at how those are changing and things with periodic surveys that have happened over the years there. Hopefully that answered your question a little bit anyway.
Seems like it always comes down to nutrients, okay? It's nutrients, and Lake Superior is limited, and
Yeah.
many of our lakes are too.
That's true. Lake Superior is very low in any nutrients, and the only area that really you see any type of bloom happen is on that south shore, and it's usually near a river outlet, and it's always in the middle of the summer. And there was recently a bunch of projects funded to look at. They had a couple of algae blooms right near the Superior entry within the last 10 years, and so it's been. But historically, there had been blooms before, so it was really not that new quite yet. I wouldn't say, yeah.
What the big picture, the other Great Lakes are all pretty much polluted and have invasives. What do you see for the big picture in Lake Superior?
So do I see that same thing coming in Lake Superior? Is that? Yeah. To be honest, I think Lake Superior is cold enough that it'll take a while for that type of thing to happen. I don't see the same nutrient problem because there's not a heavy agricultural influence on the watershed. I mean, if I remember correctly, it's like 95% forested. Now, if something changes where land use changes around the basin, you might see an increase in phosphorus which is the limiting nutrient out there that could increase it. But right now, I mean, it's right at detection. So we can barely measure phosphorus in Lake Superior. That's how low it is. It's about 1 milligram per liter. And when you're thinking about blooms, they usually start forming around 25, 30, something like that. So it would take a major change, land use change, for that to happen. And phosphorus doesn't come from anywhere atmospheric. It flows in, or somebody changes the runoff to get in. It might come in through dust a little bit if somehow increased dust. But in the warming part, which also promotes blooms, I think is happening slow enough that it'll be a while before we see much of a change in overall nutrient and bloom conditions in Lake Superior. That being said, the edge of the thermal preferences for some of those invasive species, we're getting pretty close to those, especially in the near shore. There's what's called a thermal bar that sets up in the early part of the summer in the near shore. And as that warms up, some of these populations of Eurasian rough and round goby can connect and spread along shorelines and stuff. So that might happen quickly with very small changes in temperature. Yeah.
It's somewhat related about land use on the shoreline and light pollution. I don't know if is that a factor all the way out in the middle of the lake, or is it not? Is it something that's being worked on in coordination with
Wow, that's a really
land
good
use
question.
management?
Yeah, so I haven't seen anybody working on light pollution at all. But would a fish be able to see a prey item better if a ship came by? Oh yeah, you bet. But But I don't know anybody working on that. That's a really interesting idea for a proposal. Yeah. Light pollution. They're working on sound pollution from the ships. Yeah.
We've got an online question here first. Go for it.
Has introduction of Pacific salmon for sport fishing affected the food web in Lake Superior significantly? And why does this practice of planting Pacific salmon continue?
So Pacific salmon are not a very large component of the food web, and I mean we included them in the ecosystem model that we built, which allowed us to project into the future with changes. The only one that really I think would be considered a potential impact on native species would be rainbows or steelhead. Steelhead are really ubiquitous throughout the lake. Almost every tributary on the Canadian shoreline has a population, and there's quite a few on the south shore. And one of the scenarios that we ran with the ecosystem model showed that if ciscos change in abundance much, especially if they go down, rainbows would do a lot better. And the interesting thing about rainbows is that they definitely interact with coaster brook trout, which is a native species that pretty much every agency is trying to restore at this point. So that would be the only concern. Now, there's recently been a giant year class of cisco, like the likes of which we have never seen in recorded history, that happened 2.5 years ago, and so I don't see that happening. The scenario that we ran that resulted in an increase in steelhead is no longer really in play for the next 10 years, I'd say. Yep.
My question is regarding smelt runs. Are they caused by a full moon, the change in the temperature, bonfires we build on the shoreline to keep us warm? But they're a ton of fun, and I would like them to continue.
Sure. So you mean what causes the timing of the smelt runs? Yeah, some of it is related to temperature. So they like 4.1 or 4.2 degrees Celsius. So that'll cue them. I mean, it usually happens right when the ice goes out, right? So you'll see that. But I'm not aware of anything related to moon phase. It's possible. It's very possible that they would want to run on a full moon, though. You have to let me know or do some research on that. Yeah, a lot of migratory fish choose a full moon because they can see moving upstream, and so I think temperature and potentially a moon phase. But I never really saw that link. I mean, I looked for it, I guess, when I was working on rainbow smelt in the 90s. I was really trying to get them because I was using them in some feeding experiments. And then I had a grad student doing some genetics on them, and I was trying to get her to be able to sample these, effectively without having to spend more than a few days. And my predictions didn't work. So.
My question is, I've been following the Porcupine Mountain mine that they're trying to develop, and curious if there's any studies or research that could show the implications prior to this, and what do you think are the implications to that?
That's a hot one. Anything related to mining, of course, you have to worry about acid runoff and sulfates and things that highly impact plant species in particular, and certainly heavy metals. So I wouldn't be a big fan of that. How would it impact Lake Superior in general? That's a really tough question. The lake is so huge. For context, we did a study to look at the influence of carbon sources on the landscape in the lake. And we had this beautifully brilliant geochemist working with us who was able to use the radioactive carbon signature from the bomb testing in the 50s to track carbon, terrestrial carbon in the lake, and we could not detect the rivers in Lake Superior. That's how big Lake Superior is, even when we were sampling right off the mouth. So Lake Superior, I think, is so large in context, but as far as the rivers and the watershed around that mine, definitely, it will cause a huge impact. Yeah, and I'm not overly qualified to talk on that one, sorry. Yeah. Oh, yeah, go ahead.
All right, this is going to be a good climate change question for you. I'm a longtime fisherman on Lake Michigan and now Lake Superior. And with climate change, we're seeing low pressure systems further south and east, and that brings a lot more northeast winds, and it piles up a lot of warm water, especially on the west shores of Lake Michigan, the south shore of, Lake Superior, all through, the Apostle Islands, all the way to Duluth Superior. Mm-hmm. What are the implications of that in the sport fishery in the future? Because we're trying to reestablish coaster brookies, brown trout, splake, and coho, and we are finding temperatures that are 60 to 65 degrees from the surface to 100 feet down in September.
Yeah, yeah. I will absolutely agree with you on the warming on the South Shore in particular, and it's going to probably gain. It'll continue to gain increased temperature every year. How will that impact coasters? It's not going to be a very good situation for them on the South Shore. Now, that being said, on Lake Superior, the interesting thing is there's what are called seiches. So when the water moves, it'll pile up. The warm water will pile up, but then it also sloshes back. So sometimes you can get upwellings, and then you'll get upwellings where there had been really warm water as well. So I don't think it'll mitigate the problem of those thermal bars and the warming on the South Shore, but it may mitigate enough to where we won't lose them. But the habitat quality for coasters is probably going to continue to go down as we see warmer and warmer summers. Yeah. Yeah, that's a great point. Clearly, you know a lot about where the thermal bars are.
Okay, you talked about a spot in the middle of Lake Superior where there's like a ridge of shells or something. I mean, what's the bottom of most of Lake Superior like?
So Lake Superior Shoals, yeah, the interesting thing about that, it's part of the same formation as the Keweenaw and Isle Royal. So a lot of it is basalt, but we did find, and there's probably, I would say there's at least a dozen major reefs there. So the spire that sticks way up to closer to the surface is really jaggedy and made completely of basalt. And then there's another one called the Central Ridge that was the one that I studied, which is pretty flat. And when we sent the ROV down there, it was gravelly. So there's clearly some evidence of glacial influence on that. And that's why the lake trout are doing very well there, because they're spawning habitat there. And that's about 80 meters in depth, up to 60 meters, so, not 180 feet deep on top. So it's not super shallow, but it's in the light, and there's plenty of those mysis there for young lake trout to feed on. So it's a really productive area. I asked the geologist, how did the gravel get on top of the Central Ridge? And we were on the same boat, and we had a long way to get back to Duluth, and he couldn't give me a straight answer on how gravel got on top of that, so I don't know. Who knows on that one? But it's mostly basalt, same formation that Keweenaw is. A lot. This is out of my area of expertise, actually. But there's from what I remember, there was two different periods of formation. One of them was from volcanism, so it's much newer, and that was less it wasn't as hard as the older material, and so that was what was eroded away by the glaciers and dug the main basins of Lake Superior. But there's also a lot of evidence of erosion down there from probably previous glacial events. But you would need to really get at a geologist to know all that stuff. Yeah.
Hey, Tom.
Uh-oh, John.
Thanks for a nice talk. Back on the topic of climate change. So, as you're aware, Lake Superior is one of the most rapidly warming lakes in the world in terms of long-term climate change impacts. One of the bizarre aspects of that is that the coldest parts of the lake, of the surface water, are the parts that are warming most rapidly. So, like offshore, deep, but at near the surface are warming at sometimes 10 times the rate of the nearshore waters. And I've always wondered, what does that mean for the fish? But then you got me interested in the thermal bar, saying that the thermal bar, which is inside the thermal bar is the warmest area, it's only warming a little bit, and they have a high sensitivity to that. So we have this bizarre thing going on where the coldest waters are warming most rapidly, the warmest waters are warming a little bit. Where does the sensitivity lie for the fish?
So let's think about the offshore. Let's think about, a mile and a half off of Lake Superior Shoal, right in the middle of it. We do see occasionally thermal stratification out there, let's say in July, but it'll be very narrow. I mean, we're talking 2 meters, and it'll warm up to maybe 12 degrees C at the most. And then if the wind switches, or you get a blow, it's gone. And the thing with the thermal bars near shore is that's why they call it the bar, is that circulation keeps the warm water in that near shore. Offshore, you can see it dissipate in 2 hours.
Even in 1998, 2016, the really warm summers?
Did they disappear offshore?
Yeah, it's like when it's 70 degrees all across the lake, a really warm summer.
Once you get off, let's say 10 miles, it's really thin. Like if you dove in, you would feel the cold immediately. Yeah, it's narrow, and I mean, there's some conditions where you can get a seiche or a blow that stacks it up out to maybe, 2 harbors ish. You'll see a real strong thermocline that's down to 15 meters. But as soon as the seiche rocks back the other way or the wind switches, it'll blow it offshore, and it just mixes. There's so much, I'll say, cold storage in Lake Superior that it just, I don't know. To me, it's difficult to really predict. But I agree with you that it's changing really rapidly. Since I shouldn't use my memory that much. But it's significant. 3 degrees in the last 20 years, roughly. 25 years, probably. The only lake I know that's changing faster is Lake Hufsagul in Mongolia. We were there, and that's about half again faster. It's a large lake in Mongolia that is warming really quickly. It's about the same latitude as Anchorage.
Another one over here, Tom.
So compared to some of our shallow lakes around here, how does the oxygen levels change from top to the really deep parts of Lake Superior, and how do the fish deal with that?
Yeah, there's no oxygen limitation in Lake Superior that I know of. And maybe see them in the bays, some really highly productive bays. But there's actually erosional features from in-lake currents at 800 feet in some areas. So anytime you get a wind event in the absence of thermal stratification, you can get really strong underwater currents. And so the mixing is amazing. I've never seen a low oxygen measurement offshore. Yep.
I have a peculiar question that's always sat in my mind when I heard it a while ago, and now I get to talk to you and confirm it. Is one of the largest salt sodium deposits belonging under the Great Lakes, and tell me about that. And what if there's an earthquake? Like, is that, I mean, I'm just so curious about this. Blows my mind.
As far as I know, the salt deposits are under Lake Michigan and it's a dolomite formation that's more east towards the other Great Lakes. But again, that's a question for a geologist. All I know is that it's from an ancient ocean or sea that was there. And I can't even put it into like the Cretaceous for you. But I think that rings a bell for some reason. But yeah, it's further east, and it's a kind of a circular dome, and that's sort of the Niagara Escarpment is part of that thing. And underneath that, there's some salt. Yeah, and they mine it like crazy over there. Yeah, but it's not under Superior.
Tom, I have a question for you. Could you tell us a little bit more about the sonar work you do and what kinds of things you can learn from
sure.
sonar?
Yeah, sonar was great. So I was fascinated by that immediately as soon as I think as soon as my dad bought one of those crazy flasher units in the 70s, you know, we fished a lot, and so I was always looking at it and trying to figure out what was going on. But when I got into graduate school, there was some really great scientific equipment available for us to use, and I worked with a guy named Lars Rudstrom, who was in Clarence Clay's lab, who was the guy that invented how to analyze sonar data. And that was at UW-Madison in the physics department. And so I was pretty lucky with the situation. And so I learned pretty quickly, first of all, you can drive actively pinging with sonar and see whatever's down there if you know what you're looking at. And then the other thing is you can watch things behave. So the great thing about sonar is you're pinging up 3 or 4 times a second, and so you can see changes in depth distribution of fish. You can see, you can even see individual interactions between fish sometimes, depending on how you, what type of unit you have and how you analyze it. So the things that I did with it were look at these vertical movements. So we would look at time frames on the order of minutes, and we would watch the entire population move up. And then we would watch them all night, and then we watched them go back down again. And there's a really interesting thing that happens in the middle of the day where they kind of go up again and go back down, and I think that's predator-prey. And the problem in Lake Superior is that it's too deep. So we need to send a submersible or a AUV or autonomous underwater vehicle now, and we're starting to do that. We're starting to use sonar units on these. You can actually control them remotely and send them to wherever you want, ping up and down and to the side and whatever you want to do, and that gives you the resolution to look at some of these predator-prey interactions. So you can measure behavioral changes, you can measure absolute density, you can measure fish sizes and how the fishes of different sizes move differently. And so that was a lot of the stuff that we did. But I also worked with the Minnesota DNR, the Wisconsin DNR, on Lake Superior to establish quotas for the fisheries. And the sonar was our main approach to estimating accurately total abundance and total population size within their jurisdiction to allow harvest. And the reason why sonar is so nice is that the fish really can't feel or hear the sound, and so there's no bias. Whereas if you set a gill net, you only catch a sub-portion of the fish population, and it's very difficult to tell what you missed. With this, you can pretty well see everything, and so it's nicer. It's called a fishery independent survey a lot of times, and we've been working with all the agencies on the lake to establish those quotas that are not necessarily based on the fishery itself. And there's a lot of people that don't believe some of the stock assessment models, and they want a different answer just to see if it agrees or not. So we've been doing a lot of that over the years.
I have a question.
We're seeing on the sail drones that we see out in the lake?
Yeah. So the question was, there's some sail drones that have been out on Lake Superior, and sail drones are actually, they use the wind, so they're very economical to use once you pay for them. And So but you don't have to buy diesel or anything to go out there. And so, yeah, you can just let these sail drones, program them to go in a direction and turn around and come back. And it uses wind, and they're pinging the whole way. So you can do surveys with sail, and that's really catching on now in Lake Superior and other Great Lakes.
Question here.
Yep.
I think about these fish going on their migration from deep to shallow, and how you say some of them live in the deepest depths. And once upon a time, in an ocean far, far away, I dropped a camera lens out of a helicopter twice. And after the second one, I was haunted with these images of this camera lens sinking to the bottom of the ocean and at some point completely imploding upon itself. And I'm really curious how these fish don't implode on their fast
Oh, good question.
dive down to the bottom of the lake.
How they don't implode?
Yeah.
Okay, so the deepest water fish in Lake Superior, the one I was telling you about, the big eye Cisco and bloater in particular, they're called bloater because when you pull them up, their swim bladder overinflates, and they kind of, sometimes they even pop. But the kai is, and those two species are higher in fat content than the Cisco's, the shallow water one, even though the Cisco is fairly high in fat content already. So they use these low density lipids to control buoyancy. And so their swim bladder may not even be completely inflated. And when they lose it, the oil stops any of that compression and reduces the bends too from going up and down. So fat will actually absorb nitrogen. We haven't been successful in keeping the Cisco's alive in the lab, but the Ciscoette, the one that I was telling you about, which is 60% fat sometimes, the lake trout, they're fine. 60% fat. We brought them up from 100 meters before and put them in a cooler with hypersaturated oxygen for a day, and they were feeding immediately. I mean, they got over it almost immediately. So I think there's a lot to do with their oil and fat content, and that is an adaptation to mitigate this vertical movement and compression problems that some fish may experience.
Yeah, I don't know if they do this on Lake Superior, but around here, the DNR does some shocking around the shoreline on our lake once a year, I think. So is that an accurate measure of what the population is of a lake? I think they may use it to set bag limits, et cetera.
So electrofishing is, I think, one of the least biased approaches, and is certainly effective if the fish are there. But that's really the trick, is to do it at the right time. So usually what they're doing, I think probably, was it in the fall?
Yes.
Yeah, so the fall surveys are to identify the young of the year walleye densities. And that's a pretty good way to do it, because they're still pretty shallow at that time. Now, electrofishing isn't effective, like I would say, past about 7 feet deep, 6 or 7 feet deep, because it doesn't, you can't get the electricity down far enough, depending on the lake.
I have one from online. It's just, how do extreme rain events on the Lake Superior watershed affect the fishery?
I think I know who this is, actually. So there has been some really huge, especially in June, rain events on Lake Superior where we've had, Highway 53 and 2 washed out in the middle of Superior a couple years ago, right when we were having the International Char Symposium there. And so people were having to divert and go around. We had to move the schedule around and everything. And the plumes of sediment that you see from these storms really reach out into the lake. The whole western arm turned brown from that one. And so I believe that there is some significant impacts of some phosphorus addition impacts, and then especially the cloud of sediment that caused decreased water clarity. I mean, you were seeing fish species inshore that were normally 20 miles offshore because it was dark. They didn't care about predation anymore. But the overall message, I think, if I remember correctly, so Bob Sterner was studying this, Liz Miner was studying this at the Large Lakes Observatory in Duluth, and I think if I remember correctly, there wasn't a significant problem related to blooming from the increase in sediments, but there was probably burial of critical spawning habitat especially near the river mouths, that no doubt happened. Same storm events happened near Bad River as well. And I think those are the ones that whomever's asking this question is wondering about. And there's certainly burying habitat.
This young man up here brought up fish population assessments. And before that, you were talking about the ability of sonar. Is there any freshwater application of those sonars that we can do to get a better population estimate for our walleyes, which determine a lot?
Yeah, we've used them for walleye during the summer offshore at night, especially in lakes that have Cisco or smelt in them. And you can estimate their density pretty easily, separate it from all the other fish because they're bigger, yeah. Yeah, we've done it. And the DNR has got some of the best equipment available already. They have their own sonar unit and they're capable of estimating densities for sure. So certainly, they tend to gravitate towards mark recapture to get the population sizes, but you could augment it with some additional secondary estimates. Yeah, I think, and we've done it. There's a couple of papers that detail how we did it pretty clearly. Yep.
Yeah, I was just wondering, like, just so we can all go like, oh, did you know? Like, how many fish species with all the variations are there in Lake Superior and or in the Lake Superior ecosystem between the fish and the shrimp and the plankton?
How many species are there? Yeah, in Lake Superior, there's about 85 or so. Like I said, one that we thought wasn't there just showed up. That was a native. But yeah, it's between 80 and 90 for sure. And they're a combination of native and exotic species or introduced species. Yep.
Is there anything to the fact that these old wives' tales of extremely large fish? I mean, like, I'm not talking like Jaws, but I mean very abnormally large fish. You have a large body of water.
Sure. I would believe a 70-pound lake trout. I would believe that. I've seen them in the Apostles that were so big that we couldn't even lift them. They were tearing the net. They were so heavy, yeah. And I don't think they were over 60 pounds, but they were certainly 50. Yeah, there's some really big lake trout out there. I don't know if over 70 pounds, though. Maybe, especially in Canadian waters where some of the lamprey populations didn't quite establish very well. There might be some old ones. But you're talking, a fish that big would be over 100 years old, you know. Yeah, there was one in the Apostles that was only 28 inches that was 75 years old. Yeah. They had to kill that one. They had caught it and tagged it like 4 times over the course of 25 years, and it kept coming back the same age from the scales. So they had to kill it to use the otolith to tell exactly how old it was. And yeah, it was damn scientists, right? Yeah.
And have you heard about the underground channel from Lake Superior to Trout Lake? You know?
I haven't seen the paper on that one yet, no.
We're working on it. Well, thank you very much, Dr. Tom Robick. Thank you to all of you who participated tonight, and to our sponsors, the Lakeland chapter of the UW Alumni Association, Rocky Reef Brewing, Minocqua Public Library, UW Kemp Natural Resources Station, Trout Lake Station, and WXPR Radio, and the Brittingham Foundation. We hope to see you here again next month, February 6th. It's always the first Thursday of the month, where we'll hear from Mark Pauley on PFAS, or the forever chemicals in our water. And you can stay informed through our email list or website for more information on this event. And we have a sign-up sheet. If you aren't already on that, you can sign up and back or go to our website. We'll see you next month.